Astronomers are currently observing a nearby orange dwarf that hosts a unique system of 6 planets. The TOI 178 planetary system, which is approximately 7.1 billion years old, is host to 6 planets that range from super-Earths to mini-Neptunes. 5 of these planets are locked in a rare rhythm around their parent star. Studying this planetary system could provide important information about how planets form and evolve. The TOI 178 star is a K-type star located approximately 205 light-years away in the constellation of Sculptor, also known as TIC 25-184-8941, to mass J0029-1228, 30-27-133, and TYC 6991-00475-1. This system harbors at least 6 transiting planets. The innermost planet, TOI 178b, completes an orbit around its star in just 1.9 days, while the outermost world, TOI 178g, takes 10 times longer to orbit the star. They have sizes ranging from approximately 1 to 3 times the size of our Earth, while their masses are 1.5 to 30 times the mass of our Earth. It appears there is a planet as dense as the Earth right next to a very fluffy planet with half the density of Neptune, followed by a planet with the density of Neptune. It is not what they are used to in terms of planetary system and how the planets appear. In an effort to investigate the architecture of the TOI 178 system, researchers and astronomers alike have analyzed data from the European Space Agency's CHEOPS satellite, the ground-based Espresso instrument on ESO's Very Large Telescope, and the NGTS and Speculus surveys at ESO's Paranal Observatory. The astronomers found that all TOI 178 planets, but the one closest to the star, are locked in a rhythmic dance as they move in their orbits. In other words, they are in resonance. This means that there are patterns that repeat themselves as the planets go around the star, with some planets aligning every few orbits. Based on astronomical observations, the 5 outer planets in the system follow an 189643 chain of resonance, one of the longest yet discovered in a system of planets, while the second planet from the star completes 18 orbits, the third planet from the star completes 9, and so on. In fact, the researchers initially only found 5 planets in the system, but by following this resonant rhythm, they calculated where in its orbit an additional planet would be when they next had a window to observe this system. The orbits in this system are very well ordered, quite unique as well, and this indicates that this system has evolved quite gently since its start. If the system had been significantly disturbed early in its life, for example by a giant impact, this fragile configuration of orbits would not have survived for scientists to do an observation today. Astronomers have now done some calculations, and the likelihood that the signal came from another advanced civilization seems to be quite disappointing. In total, the telescope gathered 26 hours of data, but when astronomers analyzed it in more detail, they noticed something quite weird. A single pure tone at a frequency of 982.02 megahertz that appeared 5 times in the data. The signal was first reported in 2020 in The Guardian. The article raised the possibility that the signal may be evidence of an advanced civilization on Proxima Centauri, a red dwarf star that is known to have an Earth-sized planet orbiting in its habitable zone. Many persons also wondered if this could also be a sign of extraterrestrial intelligence. The new signal was found by researchers at the Breakthrough Listen project, an international collaboration of astronomers searching for evidence of extraterrestrial intelligence. Of course, they call the signal Breakthrough Listen Candidate 1 or BLC-1. The signal is quite interesting because narrowband tones do not generally occur in nature, which instead tends to produce broadband noise, but BLC-1 has all the characteristics of a technosignature, one that originates from a technologically capable civilization. By far, the most likely origin is Earth. Most signals of this kind are quickly attributed to radio interference from nearby mobile phones, microwave ovens, passing cars, aircraft, and satellites, and such. The team analyzing the signal have yet to find an obvious source. As they say, the frequency of the signal drifts slightly over time, a phenomenon consistent with a signal from a rotating or orbiting body. This has increased the intrigue. The principle has a storied past. It is named after the 14th century Copernicus, who suggested that the Earth did not sit at the center of the universe and instead orbited the Sun. Almost 30 years ago, the astronomer Richard Gott used the same principle to show with 90% confidence that our species is likely to survive for at least 200,000 years, but no more than 8 million years. It's just a question of slotting in numbers. They know our species is about 200,000 years old, which must be at least 2.5% of the total. That suggests with 95% confidence that humanity should be around for at least another 200,000 years, but not longer than 8 million years. Like, comment, share, and subscribe. Thanks for watching. Goodbye.